Yeah, welcome again. We are on the fourth video of the unit number 4 for robotics and automation, intended for the aerospace students of third year. The course is robotics and automation, and I am Dr. Ilangovan, professor in the Department of Aerospace, SNS College of Technology. Let's continue from where we have left last time. For the syllabus is given here. We were talking about the robo sensors. Okay, the various output devices of PLC we had already seen. We also looked at the supervisory control and the data acquisition. What is a SCADA and the working of the SCADA. We moved on in the previous unit video on the robo sensors. A robo sensor is used to measure the condition of a robo and its surrounding environment. Right. Okay. What are the various sensors that are being used in a robo? Sensors are used to measure some feature of the world, such as the light, sound, or pressure, and convert the measurement into electrical signals, usually a voltage or a current. Now, the output of a given sensor can easily be converted into an electrical representation, or it could be a light or a sound, and the sensing includes activities such as seeing, hearing, touching, smelling, and measuring the distance, etc. Now, let us see what are the name of some of the robots are being sensors that are being used. Let's continue here. We classify the sensors in robots in two different ways. A wide variety of devices are being used in robot and to obtain information. Now they include not only transducers for physical quantities such as microphones or sounds, but also data processing input devices such as keyboard or for the textual information and specialized sensors. The sensors in robo are classified as ex extero extero septas. Okay, pardon me on that. And then or which is also called the external sensors for the measurement of robots or on the environment and, parameters, or the proprioceptors, okay, or the internal sensors for the measurement of robots for the internal parameters. So one for the external parameters and one for the internal parameters, right? Now you have something like contact sensors, like seeing, etc. All that. Contact sensing is one of the most basic requirement of any manipulator. Manipulator is the robot itself and interacting physically with the environment in a non-structured manner. It is the ability of the robot to determine the shape, size, weight, or even the surface texture of a robot of an object by touching it. The function of the contact sensors in controlling or manipulating can be classified into the basic material handling and assembly operations like searching, detecting a part by sensitive touch sensors or the hand exterior, just moving out and then without touching the part, or the recognition. Once you touch that, determining and identify the position or the orientation of the part again without moving it by touching by sensitive touch sensors with high spatial resolution. Then you have the grasping, acquiring the part by deformable roundish fingers, which it will be mounted on the surfaces. Okay. The next one is the moving or placing the or joining or inserting into a with the aid of a force. You try to assemble them. Now that these are the four different kinds of function that the robot uses the sensors to do that. Exteroceptors, or the external sensors, are that measure the position or the force type interaction of the robot with its environment. You have the contact and the non-contact type. The touch sensors are the electronics sensors that detect the touch. They operate as a switch when touched. These sensors use lamps, touch screens, or of the mobile, etc. The touch sensors often offer an intuitive user interface. Very simple. Just you have the touch screen monitors itself for the laptop. I don't have that in my laptop, but then there are Monitor is where you can touch and then you can work on that. Now it's very similar to the phone that you are on an iPhone or any Android phone that you use it. Okay. Now based on their function, there are two types of touch sensors. One is the capacitive sensor, the other one is the resistive sensor. Capacitive sensor work by measuring the capacitance and are seen in portable devices. Now they are durable, robust, and attractive, and with low cost. The resistive sensor don't depend on any electrical properties for operation. These sensors work by measuring the pressure applied to their surface. Then the tactile sensor can be classified as touch sensor. Touch sensor, they are binary output signal. They may be mounted on the outer and inner surface of each finger. Outer mounted sensors may be used for searching for an object and possibly determine its identity, position, and orientation. The inner mounted sensors can be used to obtain information about an object before it is acquired, about grasping for forces. Before I go and grasp, I have it on the inner one. I take the understanding whether it is available or not, and or a workpiece with slippage during the acquisition. Okay, the microswitch are most commonly used and expensive kind of sensor, and when and sensor with either turn on. I don't know what is behind it, and the contact is made. Okay, let's look at it a little later. Right. The types of contact sensors. Tactile sensor used for identifying the control directly the interaction between the robo and the end effector of the environment. Now, tactile sensors find their use in various locations of a robo system, including joints between robo links, wrist arm and end effector, the finger points, and the fingertip. It is important for assembly and for quality. For example, pressure sensors are used for part orientation and gripping force. There are robots which can hold an egg also. It understands how much pressure that is required to hold a eggshell. Now, piezoelectric sensors are used for continuous pressure monitoring. Right. The tactile sensor can be classified as force sensors and then stress sensors. In the force sensors measures the amount of force and the torque exerted by the mechanical hand. The interaction forces and torques which appear during the mechanical assembly operations at a robo hand level can be measured by sensors mounted on the joints or on manipulator wrist. Individual stress sensors usually respond only to force in one direction on them. However, combination of two or more can report forces as well as torques in two or three directions. Strain gauges are used to make force sensors, torque sensors, and measure them both the kinds of stresses simultaneously. A force sensor is defined as a transducer that converts an input mechanical load of weight, tension, compression, or the pressure into an electrical output signal or the load cell definition. Force sensors are also commonly known as force transducers. Okay. Now let us see if that is the end of this, or okay, yeah, we have the application of tactile sensors in robotics. The simplest type of tactile sensor is the gripper, that is equipped with an array of miniature micro switches. It can use to determine the presence or absence of an object at a particular point or an array of points. The advanced type of tactile sensor uses arrays of pressure sensitive piezoelectric material. This material conducts electric current when stressed. More pressure applied to the material for more electrical current is pursued. This is essential where gripper is handling delicate fragile objects so that the robo will not apply too much force or crush the object it is holding. Okay. So this is the last slide.